introduce Kristie Walker. She teaches soils and turf classes here in the Crookston campus, and she'll be using some PowerPoint slides to walk us through some information about soils and soil fertility. So thank you very much, Christina.
Thank you, Linda. Hi, everyone. Kristie Walker here. Just wanted to make you aware of, on the Moodle page, I put everything that I'm going to be using, PDF of the PowerPoint, some handouts, and some resources I put on the Moodle site for you. So you have those whenever you want to look at them. If you want to pull them up separately, you can certainly do that so you can get a closer image of everything. Like Linda said, I teach intro soils here on the Crookston campus, as well as soil morphology. I also teach soil fertility. So right now, I'm actually teaching soil fertility, and we just started last week. So this is a perfect seminar to do right now as I get ready to go through the semester on soil fertility. I have a lot of topics, and based on your questions, we can spend more time on soil sampling if we need to, or interpreting soil test reports. So throughout the seminar, just send in your questions, and I can kind of gear the PowerPoint to more what your needs are. The PowerPoint is a little bit long for the time that we have, but I wanted to make sure that I included really good information for you as a resource that you can go back to if we don't cover everything that's in the PowerPoint. So I don't know if you can see me, but I'm going to pull up the PowerPoint. Okay, so I thought what we'd do is talk a little bit just general about soils and soil fertility and soil testing, and then move into how to properly take a soil sample, and then talk about soil testing a little bit more in detail, and then talk about how to interpret soil test reports and how to come up with recommendations. I geared this more towards gardens and turf, but I did include fertility recommendations for agronomic crops as well. So you've got information if we don't cover everything. Okay. So what is soil? Most of my students the first day of school say it's dirt. It's not dirt unless it gets on your shoes, right, or in your fingernails or whatnot. Soil is a natural resource, and it is rich with mineral particles such as sand, silt, and clay, organic matter, which we'll talk about provides us with nutrients, gases, some good, some bad, but nutrients is what we're going to be focused on today, and with water gives us a good medium for plant growth and development. So typically the preferred soil composition would be about 50% solids, which would include about 4 to 5% organic matter, and then 50% pore space. And typically we're talking about a silt loam would kind of fit all of those needs. So obviously we want a soil that's going to provide all of those essential nutrients that we need for plant growth and development. We call those our macro and micronutrients. If we don't have those nutrients in the soil, that's when we have to add back through the process of fertilizing. So soil fertility is basically determining the status of the soil in regards to those essential nutrients for plant growth. However, we also have to take a look and see if we have any toxic concentrations of any elements, which can happen at specific pHs. And you'll notice if you do any gardening and whatsoever, that soil fertility tends to be plant specific. So depending on what you're growing, you'll have to do a little bit of digging for extra information, and those are recommendations are provided for you on the Moodle site. So soil quality is kind of a new buzzword, if you will. It measures the ability of a soil to carry out those functions, such as supplying nutrients and nutrient recycling. And if we get really into intro soils, that would be our chemical, physical, and biological processes within the soil. Obviously, soil erosion, salt accumulation, and the big thing, nutrient depletion, when we harvest leads to soil degradation. And another buzzword is how resilient a soil is to recover from disturbances like nutrient depletion. So soil testing basically measures all of those plant available nutrients in the soil, and then based on that information we can interpret those results and get recommendations. So the idea here is, especially when we talk about crops and with turf, is to come up with environmentally friendly fertilizer recommendations, and the first step to being able to do that is to actually do a soil test and see what those nutrients are that we need. So let me move this down just a little bit. So picture there, steps in soil testing. We're going to sample. In the lab, we do all of our analysis, interpretation, and recommendations. But in general, sample collection is where we can go wrong. It's the greatest source of error. And when you think about it, you're only taking about 2 to 5 grams of your soil sample for analysis purposes. And so it's really important to have what we call a representative sample of your given area. So soil sampling takes a little bit of homework first, because you have to get the appropriate materials before you actually go out and do soil sampling. So you have to obtain the proper forms and containers from the lab. You always want to use a clean plastic bucket, a clean soil probe, auger, spade, and if it's a large area, draw and map out the area. This is a picture of the soil testing website on the Twin Cities campus. This link is provided for you on the Moodle site. Last year the internet went out on me for the soil survey, so I always make sure I do kind of like a picture screen of everything. But just kind of, this isn't actual internet, but just to kind of show you what the information is. Can't get lost on this site. How to submit, about the analysis process, understanding your soil test report. That's where most people have the most difficulty. There's a nice little section there on frequently asked questions, and then there's also another link about resources, and so you'll find some additional information there as well. This is a PDF of that initial information that you need for soil sampling. And this is also a PDF on the Moodle site. And are we a little bit lagging behind a little bit? There we go. So basically just kind of gives you the information. You have to remember that when you send in a soil sample, you're sending in information to the soil testing laboratory and providing them information. But most importantly, everybody wants to know how much it's going to cost.
Hold a second. Allison, are you seeing the soil testing PDF form?
Yes. Yep.
Okay.
Just fine.
We're a little delayed on our screen in front of us. So sorry about that. Most people want to know how much it costs, and so a regular test from the soil testing facility down the Twin Cities campus is $17. It includes organic matter, phosphorus determination, potassium, pH, lime requirement. We call that a buffer pH, and it'll also estimate your texture. If you want to add to that basic report, then you're going to have to pay a little bit for additional information like soluble salts, sulfur, nitrate, some of our micronutrients. One of the things that it'll tell you, though, is that for those additional tests, it really doesn't give you any kind of interpretation or recommendations for those. So you might have to use some of those PDFs that I provided to give you some additional information, because what you'll find out is with a lot of specialty crops, those micronutrients come into play. And this is just the back side. Talks about how to take a soil sample, and so it's kind of hard to see on the screen, so I'll blow it up on the next screen. This slide here kind of goes through the process of how to take a soil sample. This is from my home lawn in Indiana. So clean bucket. You know, have the soil sample bag or container that you're going to use, and that depends on the soil testing facility. This one's actually from AgVise, and so, or AgVise has a bag that looks very much like this, and then you can see me there with my soil probe. For turf, you're usually taking 0 to 3 to 0 to 4 inches. The soil testing website for the main campus shows 0 to 3, but what you'll notice right here at the top of this sample is grass and thatch. And you'll see here that I'm removing that. So that's why I go ahead and take 4 inches down, because you want to remove that thatch and the grass on the top of that sample. So once you take all of your subsamples, you're going to mix them. So that's why you want to make sure you have a clean plastic bucket. And then you're going to let those dry and break those up. And that becomes your composite sample, or the sample that you actually put in the bag. And then, of course, you have to make sure that the appropriate paperwork goes with the sample. And, of course, they want their money too, right? So checks, no cash. One thing to keep in mind is to sample by soil type. So a couple of things you want to keep in mind is don't mix soil colors, light and dark. Don't mix soils from different slopes or different textures, and areas that you manage differently, whether that be with crops or actually different fertilizer management practices. You'll want to keep those as separate samples. Also, if you have an area that you're concerned about, you'll want to send in 2 samples, one sample from the area you're concerned about, and then another area as well. So a composite sample, this kind of confuses my intro soil students. A composite sample is basically what goes in the bag. Okay, so it's that one sample that you're paying $17 for. We usually say that a composite sample doesn't represent more than 18 acres. And if we're talking about gardens and lawns, that's pretty big, okay? But keep in mind, you're usually taking 12 to 15 subsamples, or what we refer to as cores, and then mixing those up, and that becomes your composite that goes into the bag or the container, depending on the soil testing facility. That one sample that you're paying $17 for. So here's a picture that was on the website that kind of shows you the backyard and the front yard. If we're talking about lawns, I never mix the front yard and the backyard, because typically you'll have one area that's under shade and one area that's full sun. But you'll see that here you've got 1, 2, 3, 4, 5. I say around 12 to 15, because you want to fill that bag to the line. So you want to make sure you have enough material. And then you'll have another separate bag or composite for the front yard. And I realize that's going to be 2 samples, so you're increasing the cost of soil testing, and that's why people start to mix, is they just want to send in one. But it's a good thing to do too. Okay, so depth of sampling, you can just mark with your probe or auger or spade. When you're talking about existing grass, 0, like I said before, I push it to 4 because you need to get rid of the thatch and the grass. New grass, 0 to 6 inches. Garden, 0 to 6 inches. Trees and shrubs, 0 to 12. How often do you take samples? Pretty much whenever you want to, right? If you're paying for it. I would just keep in mind that if you're going to compare samples from year to year, like if you're trying to see if a fertility management plan is working for you or not, you'll want to sample the same time each year if you're going to make some comparisons. So if you always sample in spring, then sample the next time in spring as well. Okay, you're just going to do it more often if you're trying to adjust your fertility management plans. And just some general comments, you know, like I said before, clean equipment, clean buckets, all of those are going to be really important so you don't contaminate your sample. Another thing to keep in mind is if you let it air dry, some of that moisture is going to come out, and you're not going to pay that much on postage to send it in. Okay. This is another picture of the internet, and it shows you the test. The regular series I said before includes phosphorus, potassium, pH, lime requirement, organic matter, and estimates the soil texture. Anything you add to that is going to cost you a little bit more money. But it depends on the soil testing facility. I mean, those regular tests could be different. Like, for example, at AgVise, they include cation exchange capacity, which we're going to talk about in just a minute. That gives you an idea of how well the soil is able to hold on to those nutrients. So if there's a particular test you're wanting, you might want to shop around to see which is the better deal. One of the things that I always throw in here is the reliability of various soil tests. For my soil fertility class, they basically take soil samples, and then throughout the whole entire semester, they run tests each week, just like you would for a soil testing laboratory. So, like, for example, it takes us about 3 weeks to run cation exchange capacity, whereas when you send in your soil sample, it just takes them a couple of days. But we talk about the reliability of various soil tests. So you'll notice a lot of those that we talked about in the regular tests are good, they're reliable, but there are also some that are not so reliable based on differences in test, extractants, and things like that. It has to do with laboratory analysis, but just realize that some of the analyses are not as good as the others. This is an example of a soil test report that's provided in the PowerPoint as well as a PDF. We're going to talk about these towards the end on how to interpret a soil test. Depending on where you take your sample from or where you send your soil test to, which testing facility is trying to interpret their report, if you will. Some testing facilities will just send you all the numbers and won't give you any interpretation whatsoever. Some will give you some interpretation, but not all, depending on what the test is for. So we'll talk about some of those as we go through what you typically find on a soil test report. So one of the first things, well, maybe I should ask if anybody has any questions first before we kind of jump into the different parts or different analysis on the soil test report. Are there any questions so far?
Remember to, if you have questions, to go ahead and go to the chat pod, and we can check there.
I am noticing a question here popping up. Sheldon's wondering, any thoughts on soil sampling areas that have been fallow for 20 or more years?
Well, you definitely would want to test that, especially if you are going to plant something there. I mean, it just depends on what your interests are. I mean, it would be definitely interesting to see the soil test results for that particular area. I mean, if you're going to plant, I always suggest doing a soil test. And the reason why is it's not just to know about nutrients, it's to be efficient and environmentally safe. So my rule is if you've got it in the soil, then you don't need to apply it. And so I always say do a soil test first. But yeah, sure, do a soil test. That would be interesting. I'd like to see those results. Okay, so any others? Okay, so what I thought we'd do now is kind of go through, oh, there's another question. Let's see.
If there's a new area that hasn't been a garden yet, but will be, you go down 4 inches or 6 inches?
Well, it depends if you're going to add anything to the soil and build it up a little bit. So if you're just going to create a new area and not add any topsoil to the area or anything like that, then I would go down to the 6 inches. It's really important. I always tell my students that look at what you're growing and what the average rooting depth is, because then you can adjust how deep you want to take your soil samples based on that. And so like if you have a garden, you have it divided up into certain areas. You know, maybe one section you have for tomatoes and the other section you have for squash or something like that. Then I would take your soil test. I'd take a composite from each of the areas, especially if you don't rotate within your garden. But when you're first starting a garden, it's all supposed to generally be, well, at least I guess it depends on how big your garden is. You know, if it's a smaller garden, you could just take one composite, so just samples around the whole new area, and then turn it into a composite. But it really just depends on the area. If you've got different soil textures, different soil colors, different areas, then you would probably want to send in more than one composite. Okay, so organic matter is pretty important. In the turf world, you can actually have too much organic matter, but organic matter is one of those factors that help us go in to determine what the cation exchange capacity of the soil, or how well it's able to hold on to nutrients. The typical range is about 2 to 4%. For us in the turf world, when we get above 4%, we have to actually do some cultivation practices to reduce the organic matter. But it is a huge reserve of nutrients once it's fully decomposed. And so the nitrogen cycle, if you think about decomposition and mineralization, you basically go from organic material, the microorganisms break it down through a process of mineralization into forms the plant can take up for plant growth and development. So for nitrogen, that would be ammonium and nitrate. So soil organic matter is basically plant, animal, and microbial residues in all stages of decomposition within the soil. And then you have one component of that that's what we call the soil humus, that's pretty resistant to breakdown. And so in soils, soil organic matter influences a number of biological, physical, and chemical properties. But since we're talking mostly about soil fertility, the more organic matter you have in the soil, the higher the cation exchange capacity is. And so it provides nitrogen, phosphorus, sulfur, and some of our trace metals as well. And then it also provides or helps influences infiltration and retention of water through the profile as well. And remember, we need water and nutrients for plant growth and development. Soil organic matter is composed of living biomass, identifiable dead tissue, and non-living, non-tissue. But that's kind of getting into a little bit too much detail. What we're looking for on a soil test report is the percentage of soil organic matter that you have, and you're wanting typically around 2 to 4%. If you're low, then you would want to add some organic amendments to the soil to improve your soil organic matter. Just keep in mind, 1% soil organic matter typically releases about 1/4 to 1/2 pound of nitrogen per 1,000 square feet. So that would be square feet is what we usually, the units that we use for lawns for smaller areas versus acres. So it does provide, once it's broken down by micronutrients or microorganisms, it provides nutrients into the soil. So cation exchange capacity, CEC, is typically used on a soil test report. It's not tested for on the Twin Cities soil testing facility. Basically, it's the addition of your basic and acidic cations. So like, for example, the basics would be potassium, magnesium, calcium, and sodium. And so once you have those concentrations, plus your acidic ones, hydrogen and aluminum, you'd be able to add those up and determine your CEC. CEC basically tells us how well that particular soil is to uptake, well, I won't say uptake, to hold on to nutrients. So as CEC increases, the soil's ability to hold on to those nutrients also increases. And it also helps in filtering out impurities and potential water contaminants in the soil. And CEC, when we talk about the importance of it, it also helps buffer the soil against rapid changes in pH, and that's a good and a bad thing that we're going to talk about it in a few minutes. Obviously, most of us want to adjust pH, but it's because of that buffering system in the soil that it takes so much effort and so much material to either increase or decrease the soil pH. So I like to show on this little picture here, basically this is a soil particle. These little negative areas or negative signs, those are the cation exchange sites, and those are where the basic and acidic cations attach, if you will, to the soil particle. And so I mentioned before, we're talking about the basic and acidic cations. So on a soil test report, you have to analyze for each of these nutrients before determining the CEC. So like, for example, on the soil testing facility on the Twin Cities campus, potassium is tested for in the regular test, but calcium, magnesium are not. And so that's why they typically don't do CEC. But basically, I was mentioning before, for our students, we take a week. And so 1 week we're analyzing the basic, 1 week we're analyzing the acidics, and then once we add those together, it gives us the CEC of the soil. And with that CEC calculation, you can also figure out base saturation, which is what is the percentage of that nutrient on the exchange sites. And so during soil testing, they're typically adding some sort of an extractant to knock all these cations off the exchange sites into solution where it can be analyzed. So here's some good numbers for you. Mill equivalents per 100 grams is the same thing as centimoles per kilogram of charge. And so based on the soil type, you'll see differences in cation exchange capacity. So a great example, like for a sand-based green or a sandy soil, doesn't really have a high CEC. If you have that type of soil texture, then you're going to want to apply nutrients to the soil, right? Because it's not going to have a very high CEC. Clay and organic matter, huge numbers, right? And so based on what kind of texture you have in your garden or your lawn, you may need to adjust your fertility management plan based on those textures. So pH. pH is pretty easy, although my students kind of freak out about it. They think, you know, it's a lot of chemistry. It reminds them of chemistry, I guess. But basically, it reflects the concentration of hydrogen in solution. And so basically, it's if the soil is acidic or is it alkaline or is it neutral. Okay. So this is a great picture here of the pH scale. So basically, if it's alkaline or basic, it has more hydroxyl. That's where the chemistry part comes in. If it's acidic, it has more hydrogen ions in it. Typically, soil ranges from about 3 to 8 on pH. Why is it important for nutrients is that all plants pretty much have an optimum pH. And lots of times we're growing things outside that optimum pH, and we need to adjust, okay? So here's an older picture, but it's like in every textbook known to man, is the availability. So macronutrients, nitrogen, phosphorus, potassium, calcium, magnesium, sulfur, are going to be more abundant in the soil around neutral pHs. Whereas micronutrients like iron and boron, they're going to be more abundant at acidic pHs, except for the one nobody can say, molybdenum. Or as my students say, molybdenum or something like that. You can have toxicities. I'll just throw that in there. With really acidic soils, you can have aluminum and manganese toxicities that exist at low pHs. But if you're wanting to change the pH of your soil, you have to get over this, what we call the buffering capacity of the soil, okay? And what that means is it takes a lot of time, a lot of material to try to adjust, okay? So if we want to increase the pH, we're going to add liming material. If we want to decrease the pH, we're going to add sulfur, okay? And I won't bore you with those calculations, but there's all types of liming material out there. They usually contain either calcium or magnesium. If we want to lower the pH, we're usually talking about elemental sulfur, because I believe it's like 88% S. There are some fertilizers that you can use as well. And there's also some nitrogen fertilizers that you can use to alter the pH, whether you want to increase or decrease the pH. So just kind of a little summary here, talking about interpreting soil test values. We talked about organic matter, and I will say that the test that they use at most testing facilities is what we call LOI, loss on ignition. And it basically is a good method, but, well, it's cheap and it's easy to do. Let's clarify. Some of the other methods are really expensive because of the chemicals that they use and removal of those chemicals from the facility. But LOI typically will just take one day. So sometimes you can have some inconsistent results when you have sandy soils. But other than that, good test. Cation exchange capacity. The higher the value, the more fertile the soil is, right? pH, we want to be neutral. If you're too far off from neutral, that is where issues can come about. And then also depending on what your crop is, you can have some issues trying to change the pH. One thing I added on here is soluble salts. Low would be less than 1. This is an additional test that you can get. It's measured by EC, electrical conductivity, and it's another thing that you can test for. This comes into play if you're using like recycled water or you're worried about the salt content in your irrigation. You can have this test run. Also, if it's an area near the road where salt trucks are going by, it's a good way to test for salts as well. So the macronutrients and micronutrients, obviously for macronutrients we're concerned with nitrogen, phosphorus, potassium. Nitrogen is one of those that doesn't really give us the greatest test in the world, but nitrogen is extremely important for growth and development of plants. And so usually we put down nitrogen based on recommendations because it's not oftentimes part of a regular soil test analysis. So depending on the crop that you're growing, you'll want to look up the nitrogen recommendations. Okay. Obviously the forms that are taken up by the plant is ammonium, NH4+, and nitrate, NO3-. And because of that minus, and soil being a negative charge as well, nitrate can leach through the profile. So we're always looking at ways to prevent leaching losses through the profile. And obviously nitrogen is extremely important for plant growth and development. There's a lot of functions within the plant. Usually soil solution contains anywhere from 20 to 50 milligrams per liter or parts per million. In tissue, it's about on average 2.5 to 6% depending on your crop. And this is where tissue analysis would come into play. A lot of people will couple soil testing and tissue sampling together to kind of give you more of a complete idea of what's going on. And then I'll just kind of throw up here the nitrogen cycle, right? Scary, isn't it? But to kind of go back to what we were talking about with soil testing is that soil organic matter, our residues, clippings, those all have to be mineralized through microorganisms to get into inorganic forms that the plant can uptake. And I'll just kind of show you a quick picture of nitrogen deficiency. Usually it happens when we're not fertilizing correctly on turf. And so you'll see general chlorosis on the older plant tissue. And so I can show this picture. You can see in this picture, whoopsie, as you see the mist. Oh, okay, ignore that. I got too crazy with the PDF. There we go. Almost there. There we go. You can see the misapplication of nitrogen with a rotary spreader. So what did they not do? They didn't go two different directions when they were putting nitrogen down. And so you can see the chlorotic areas versus the areas that have been fertilized. So the biggest no-no here is they just went one direction instead of two different directions, right? And this is a picture of the backyard. So where it's not green, you see the chlorotic tissue there. So we've got a couple of questions here.
So the first one asks, does acid soil favor bacteria or fungi, or does alkaline soil? Is there a impact on bacteria or fungi?
Well, kind of a side note, I also teach plant pathology, so I get to talk about the good and the bad bacteria and fungi, right? I will say that typically we have issues where we're outside of the optimal or neutral areas with soil bacteria and fungi, whether you're talking about beneficial or parasitic. Especially in the turf world where we have acidic pHs, we can have issues with disease. That's kind of a loaded question, if you will, because there's all different types of microorganisms in the soil. There's different types of bacteria, different type of fungi, and depending on where you are in the nitrogen cycle depends on which microorganism is responsible for which process or which form of nitrogen. So anytime you're kind of outside optimal or neutral, you can have issues with parasitic microorganisms like bacteria and fungi. There is another question. Our soil tested 21% soil organic matter. Is it possible for soil organic matter to be too high for vegetables? Wow, 21%. That is a true organic soil, probably a histosol. Can it be too high for vegetables? I guess my question would be I'd like to know a little bit more about the soil. I was kind of curious about, does it hold a lot of water? Where you have a lot of organic material, you usually have a lot of water. And that can create anaerobic soil conditions where you get kind of the rotten egg smell, where you don't have good exchange through the profile of air and water. So in regards to the soil organic matter, I mean, that's truly organic material. The other questions would be, do you have issues with drainage? Because that can have a bad result for trying to grow crops and vegetables. And how accurate is the USDA soil survey? Can you say a bit about it? Well, last year I did a seminar on the soil survey report. soil testing is the best way to go because you can get chemical properties from the soil survey, the web soil survey for your given area. If you go to chemical properties, it will give you information on organic matter, cation exchange capacity, and pH, but it's only from when it was tested. And so when you pull that information up, there's like a little bit of info underneath that tells you when that data was collected. And usually, you know, it's only updated ever so often. But you also have to include what management implements have been since that soil test was taken. And it's very generalized information. So I would always do a soil survey. I mean, I'd always do a soil sampling and soil test report because those are just general guidelines. Oh, yeah. I forgot about that. The presentation from last year on how to use the web soil survey and also how to use the soil survey apps is on Moodle under the recorded sessions on soil quality and fertility. We had a little issue last year because we didn't have internet, but you can, it kind of goes through, you know, how to get started using the soil survey and how to find that information. But if you're wanting soil test information, you're looking for chemical properties. But again, it's older data and it doesn't include any management practices that you've incorporated since that time. So I definitely do a soil test report. Okay, so I thought I'd real quickly kind of go through some of the other nutrients so we can get to some interpretation and recommendations because if we don't have enough time, you certainly have the material here to go back and look at it. So we're talking about nitrogen. The next one would be phosphorus, and depending on the pH, depends on what form of phosphorus that you find in the soil. Obviously, optimum pH would be really important because then you get both forms. But phosphorus has some environmental conditions, and so I tell my students all the time, if you are even thinking about putting phosphorus down, always do a soil test. And if you're doing a new area, like whether it's a new lawn or a new garden, keep in mind phosphorus is really important for that initial germination and development. And so lots of times we use a 1 to 2 to 1 ratio fertilizer, so twice as much phosphorus as nitrogen and potassium when we're starting out. And so when you take your soil samples for phosphorus, I would be careful that you're not going down too far. That 0 to 3 or 0 to 4 inches is great. I wouldn't go down to 6. And the reason why is, if I can pull it up here, is this picture here. When you have initial germination and development, you don't have the root system to be able to acquiesce phosphorus further down in the profile, which you'd expect with a mature plant. So we have to provide it in the seed bed, if you will, for a seedling plant. And so when you do your soil sample to determine if you are deficient in phosphorus or need phosphorus, I would not take my sample as deep. Because obviously you got to have phosphorus for it to get that big in the long run. And I'll go back and show you some phosphorus deficiency here. You get the general purpling of the leaves, and you can see here purpling of the leaves. And this was a new home lawn that was built. This is kind of the side and the back of the yard. And I don't know if you can tell very well, but me being a soils person, the first thing I notice is I look at this picture is all the gravel that I can see in this picture. And when the house was constructed, they didn't reserve the topsoil. And so when you dig into the ground, if you know anything about soil horizons, what ends up on the top is the parent material, which is glacial till, and you get all those rocks. So it's not a good seed bed for this particular home lawn. So in addition to applying phosphorus when you just seed, sometimes when you have summer stress or a lot of pest outbreaks, we can apply phosphorus if the soil test tells us that we're deficient, to help recover from some of those stressful situations. If you do have stress, though, potassium is the best one to put down. So I'll move on to potassium, but let me just show you. This is what I typically use to figure out if I'm have high levels of phosphorus or very low levels of phosphorus. This is just a table showing you, based on the extractants that used or the test that's used, what are those sufficiency levels. These are usually provided they're actually provided in the fertilizer recommendations for crops and for the fruits and vegetables PDF, but they're also on the website for the soil testing facility. Okay, so you can refer to that information as well. And then I'll just, do we have another question?
I think you should do a sound check.
Oh.
Allison, are you hearing us okay?
Yes, I'm hearing just fine. I think, though, there was some feedback at the beginning.
Oh.
Just when I was talking, because of the way our mics are set up here. But were you seeing anyone saying they had sound issues, Linda?
Yeah, in the chat box there were some comments on sound, and people refreshed the screen, and that seemed to get them back on track.
Yeah, if you refresh, that might help a little bit too. I'll keep watching the chat box.
All right.
Okay, so the last nutrient I was going to cover is potassium, and it influences plant tolerance to drought and summer heat, which surprisingly in Minnesota has been an issue for the past couple of years. And so we usually have quite a bit of potassium in our soils here in the Midwest, but you could be deficient. One of the things to keep in mind about environmental issues is if you have sandy soils and if you have organic soils, you could have potassium leaching losses. And so that's why I always say to do a soil test for potassium to make sure. Obviously, really important in plant tolerance during stressful conditions. Potassium deficiency in turf is hardly ever an issue. Potassium deficiency in other crops, though, can exist, and what happens is you get kind of chlorosis and necrosis starting on the edges of the leaves, and they start to turn in, and on corn they'll actually roll in, and so it's actually a pretty neat deficiency to actually look at. Anytime you have root growth reduction, you could have some potassium availability issues. And so where you have acidic soils or compaction or anything like that, you could have some nematodes. Actually in turf is a huge problem as well. So you might have to do some additional cultural management practices if you have a potassium deficiency. And like I said, with anything, you just always want to do a soil test to make sure that you have a deficiency. And so this is a similar table here showing the sufficiency ranges. This one's a little bit more complicated than phosphorus. We use an ammonium acetate extractant, and so typically it's for most soils. The fine texture would be a soil that's greater than 35%. So based on the soil test report, you look at the concentration to see if you're very low, low, moderate, or high. Okay. So usually we're applying before stress and after stress for recovery with potassium applications. Okay, and there's a little bit of information on common phosphorus and potassium fertilizers. And I also included a salt index of fertilizers as well. Okay, So we won't get to it today, but I included the secondary macronutrients as well. If you take samples to the soil testing facility on the Twin Cities campus, it's not in that routine testing, if you will. So it'll be an additional amount. But I did include the secondary macronutrients, calcium, magnesium, and sulfur, and kind of gave you a little bit of description and showed you some deficiencies, if you will. So if you have questions about calcium, magnesium, and sulfur, there's information there. And then I also included kind of a summary interpreting soil test values for calcium and magnesium as well. It's kind of a go-to slide. And then micronutrients. Let me just say with micronutrients that if you think you have a micronutrient deficiency, it's really important to do a soil test and a tissue test so you can figure out if you do truly have a micronutrient deficiency. And so there's a little information in there about micronutrients and about the reliability of some of the soil tests. But I also provided a table here for common fertilizers for micronutrients as well. I just tried to include as much as possible to give you a good resource. Okay, so I thought what we'd do real quick is take a few questions and then pull up a soil test report and kind of go through the interpretation of that. Okay, so a question here: our soil tested 300 plus for potassium. Is that too high? Okay, so let me go back to that one slide so we can have something to look at. Okay, so obviously it's high. The question is it too high? Typically with potassium in Midwestern soils, they are very high. And so based on the soil test report, we usually typically don't need to add any potassium. So I wouldn't be putting down any potassium anytime soon. You've got plenty of it. If you were taking my soil fertility class, we'd go through the potassium cycle and talk about all the different ways that it's tied up in the soil. But we'd be here forever if we did that. Okay, so I'm going to pull up a soil test report. And like I said, you can look at this material as much as you want to, because there's all kinds of stuff in here. So this is a typical soil test report from University of Minnesota. And in the top here, this is just a basic soil test. So we have our organic matter, pH, Olson's and Bray P1 phosphorus. Let me give you a rundown of that. Olson's is typically what we run over here in the Crookston area and anybody who sends into AgVise, because we have alkaline soils and sandy soils. Bray P1 is the norm for Midwestern soils. Okay, so it's just a difference in extractants. And so you can kind of see, okay, 45, 40, I'm going to take the average, whatever. And then potassium there as well. So you can use those sufficiency ranges to figure out if you're high or low, but I actually like the way this is set up, because you'll see for phosphorus, P. So that means it's very high, okay? And if we go back and look at the charts, both of those are very high, 45 and 40. pH, 7.6, we have alkaline soils, okay? It's not terrible, right? But, you know, neutral, be 6, optimum 7, so 7.6 is fine. Organic material, 2.8%, so if we round that up, that's 3%. So that's fine, it's, you know, average, okay? Potassium is 89, okay? And depending on what values you're looking at, this is actually a moderate number. And you can see right here it's in the medium. So my question would be to you is do you feel like you need to add it? Okay, because to me, medium means moderate. And so I probably on the environmental side of it wouldn't add. Okay, so they give you some recommendations We have a pH of 7.6. We don't need any lime, right? The nitrogen application is on an annual basis, and this is for lawn. So that would be 4 pounds of nitrogen per 1,000 square feet for the year. So like you could put down a pound in September, a pound in October, you know, a pound in May, right? And then you could do some smaller applications over the summer if you needed it. Obviously phosphorus, we were high, so we don't have any phosphorus there. I guess the one thing that if I was going to be critical would be that for me, moderate amounts of potassium I probably wouldn't add. But this is a recommendation of 3 pounds per 1,000 square feet. So you can divide it into 3 applications of 1 pound or 2 applications of 1.5. If you have a sandy soil or organic soil, I would definitely break that down to 3 applications so you don't have any leaching losses. The next one is more for a garden. So we have 3.5% organic matter. There's a soluble salts number there, 0.5, which is low. pH, 5.6, so that's acidic. It's got a buffer pH. So based on this pH, there's a chart that you can use to determine how much lime you would need to add. And so if we look down at the lime recommendations, 20 pounds per 100 square feet. It takes a lot to get over that buffering capacity of a soil. So you have to kind of ask yourself, is it worth the cost of the material and the time to try to change the pH? And it's not immediate by any means. Okay, so Bray P1 phosphorus is low, okay, and potassium's the same. So the application or the rate for garden is in 100 square feet. So you'll see that the recommendations are a little different than what we looked at for a home lawn, okay? And also, you know, with depending on what the size of your garden is, a lot of people foliar feed with nitrogen and could do it in PK application as well. So something to keep in mind. And I just wanted to show you, this is the other resources page on the soil testing site. There's more information that I could put on the Moodle site, so I just put a link to this site and the references here, especially if you have a lot of questions about soil testing. And I'll just show up here as well. There's a link there for understanding your soil test report. It's on the link for the resources of.
Okay.
Oh, you know what? I put it on the evaluation page that you guys sent me in Google Docs.
Okay, we'll post it here under resources.
Okay, yeah. Yeah. So it's available. So with that, we went a little bit over, but if you have questions, send those in. Also, you guys have the opportunity to ask questions and continue the conversation, if you will, which might be a little bit easier on Moodle through writing, because I could actually see your question and then respond to it. So don't hesitate to do that. It's actually pretty easy for me having the Moodle site, because I have Moodle sites for all my classes, so I can take a look at your questions and get back to you. And I'm kind of talking slow because I'm actually trying to read at the same time. Okay, here's some questions.
Rosemary asks, do you have recommendations for amendments or ways of working with soil that has a high water retention other than draining it? What are some amendments that will help with that?
Ooh, okay, so soil amendments. Yes, there are amendments that you can add. I would take a look at those extension, one for fruits and vegetables and the other one for agronomic crops. You'll find more probably in the fruits and vegetables about different amendments that you can add. You know, you just have to be careful. Amendments is kind of a general term, and so, you know, they advertise for different needs, essentially, but, you know, drainage is a huge problem. especially with a high water table, because I have that situation as well. Sometimes it's a good thing, sometimes it's a bad thing. But I would take a look at that PDF from University of Minnesota on fruits and vegetables. There is some amendment information in there.
The other question is, if nitrogen is the most important nutrient, why does it not show up on the soil report?
Okay, you can get nitrogen or nitrate testing. It's very expensive. And the problem is with the testing of it. Okay, so when I was a master's and PhD student, I did like 7 years of testing for nitrogen. And basically the issue comes with variability within the field. Even in a small area, you can have huge variability of nitrogen moving, and then the testing part of it. And not to bore you with that part, but there's just not a real good testing protocol methods for it. So what we do instead is we go off of recommendations, okay? So fertilizer recommendations, nitrogen recommendations for various crops. I don't want that to sound like that's a bad thing, because it's actually not. Basically what has happened is those recommendations are based on probably over 100 years of research. And I kid you not. Those recommendations are based on your location, sometimes the type of soil that you have, but they're good recommendations. And that's about as best as we can get. I mean, you can certainly test for it, but when I add nitrate to a soil test report, we're about $30. So something to keep in mind. But recommendations are good. They're based on research, so there's nothing wrong with them.
If you want to fertilize primarily with compost, what is the best way to go about doing that as far as optimizing the application of nutrients? Would you ever want to test your compost?
Yes, you want to test your compost. One of the things with compost is you want to know something about the carbon to nitrogen ratio. So microorganisms use the carbon as an energy source. If that carbon to nitrogen ratio is too high, the microorganisms will tie up the nitrogen, making it unavailable for the plant to uptake. So you want to make sure, have that compost tested and see what that carbon and nitrogen ratio is, because if you want to fertilize using compost, you're not going to be fertilizing for a while if that carbon to nitrogen ratio is greater than 25:1, because basically the microorganisms are tying it up. It's what we call a nitrate depression that can exist, and we call it immobilization to get really technical.
Yeah, we should be recording the sound. I think, Linda, when you talk, you're a little harder to hear if you're farther from the computer.
Yeah, I am.
So I'll just keep checking the chat and see what we've got.
Okay.
You can grab any other questions.
Let's make just a reference for folks. The place to continue the discussion is posted a little further down the page on the Moodle site under additional resources for explorers and engagers. So you'll need to have a login. You'll need to be logged into the Moodle site in order to access that link called "Discuss this topic," and that'll let you ask questions, and that'll go on for a week or two, and Christina will be able to respond to the discussion there. So if you're watching this later as a recorded session, please feel free to post your question there. And then there's also right in that section a place for you to record a little video if you're logged in as well. So it's kind of fun to see who's out there. Please respond in either of those ways. It looks like the sound might be an issue tonight, and we're about it's about time to wrap up anyway. So I just want to say thank you very much, Christina. We should get our faces back here again. We'll undo the screen share.
Your image.
I think. There we go. So thank you very much for presenting
Thank
about
you.
soils, and
Thank you.
thanks for being available now for the next week or two.
Yeah.
And
Yes, just send in your questions, especially, you know, if you have anything particular that I didn't discuss today, because I want to make sure that you're getting the most out of this opportunity.
thank you very much. Thank you to Allison for helping us through the technology. I hope we'll make it a little smoother every week.
Yeah, thanks for everyone's patience tonight, and I'm impressed with the overwhelming response for the local foods college.
All right, have a good week. We'll see you next time.